Okay, hello everyone. It's a pleasure to be here today talking to Dirigina Sal. And today I'm going to talk a little about large language models or LLMs, as you may know them. And I'm going to share a couple of things that I think are really interesting. I'm going to show you first how to create powerful solutions and how are people creating solutions with really easy tools and really basic knowledges and being able to revolutionize their industries, their companies. And I'll show you how easy it is. And also, I'm going to talk a little bit about what people don't usually talk. That's why and what is happening behind the scenes of an LLM. So what are its limitations, what it is capable of doing, what it's still not capable, and where we're heading. And so uh, feel free to ask questions in the chat, and I'll probably answer them only at the end, but feel free to go writing them. And let's begin. Okay, so first, let me introduce myself. I'm Gabriel. I'm a Brazilian, and I work as a data scientist at Stefanini. I became a Google developer expert. I think it was in 2021, maybe the beginning of 2022. And I've been working with machine learning for about 5 years. I started working with machine learning, more classical machine learning. And right now, and with the advances in LLMs and natural language processing, I've started to work with that as well. And I also have a certification by Google, by GCP. It's GPC, but it's GCP, Google Cloud Platform. I'm also a professional machine learning engineer. Okay, so let me just quickly share a little bit about my journey into AI. I did business school here in Brazil, and then it's a little different area to begin. But I started business school, then I started to do a lot of online courses, and that helped me a lot to learn a lot about machine learning. Then I got my first opportunity to work and to apply those things into real world problems. And this was really helpful to cement and to help me gain more knowledge about and to really implement the tools that I was learning about. Then I did Le Wagon. That's a really good boot camp. They taught me a lot about data science from end to end. So with machine learning engineering, Google Cloud Platform, it was really good. Then I became certified by Google. I joined the experts program. I created a YouTube channel with my fiance, and I talk a little bit about how to start into AI, how to start learning, what are some core concepts. Unfortunately, it's in Portuguese. We'll expand to English later, but right now it's only in Portuguese. And right now I'm working at Stefanini in North America. Okay. So let's talk a little bit about large language models. What are these things and where are they in your life? So in this talk, for the whole talk, I want to try to simplify a lot of concepts, but I really want to go deep into what is really happening behind the scenes and with the models and trying to build. So I will use some analogies and some more simple explanations for those people that don't know a lot about programming and a lot about machine learning, but also I will try to go deep enough for the ones that already have a lot of experience. So let's first talk a little bit about LLMs. What are LLMs? What are large language models? They are basically what power these tools, ChatGPT, Bard, and Claude, that it's a really new as well, that are chatbots, that are chats, artificial intelligence chats that help you, and you can ask questions, you can talk to them, you can ask them to create recipes for you to cook in your home, you can ask historical facts, you can do a lot of stuff with them. And what powers them and the intelligence that they show and that they have, it comes from large language models, comes from these LLMs. All of them use LLMs, and these are from different companies. We're currently at a really fast-paced development of the area. So mainly Google and Microsoft are leading the charge, with Anthropic with Google and OpenAI with Microsoft. Okay, so let's define what LLM is. I really like to define things, and I will come back at this later. Don't worry, but I want you guys to focus on some of the words that I'm going to say. So I'm going to read the whole thing and go back into the words. So LLMs are machine learning models that are designed to understand and generate human-like text. These models are trained on a vast amount of data from the internet and use this training to predict the next word in a given sequence of words. This allows them to generate responses to user prompts that are contextually relevant and grammatically accurate. So let's break this down. First, machine learning model. This is a model that learns from data. This is a mathematical equation that's really good at looking at data and predicting something. That's what machine learning really simply is. It is designed to generate human-like text. That's really important. And also trained on a vast amount of data from the internet. So it uses a lot of data to train an LLM. And one of the things that I really want you to focus is it uses this training, this learned knowledge from the data to predict the next word in a given sequence of words. I will come back to this later, but this is essentially what an LLM is doing. Okay, so let's talk a little bit about history. How did we get here? What are some big milestones? I won't go deep into them, but I really like to look behind and see what brought us here. So in 2012, we had a couple of advances with neural nets and especially computer vision and with encoders. I'm not going to go deep into this, but then we have generative adversarial networks that are the GANs over there in 2014. This was one of the beginnings of generative AI. This means AI that generates new content. In 2016, we had AlphaGo. It was a huge breakthrough in reinforcement learning. Then we had the transformer architecture. I will come back to this because it's really important. And then GPTs started being released in 2018, but ChatGPT only came at 2022. And now in 2023, this generative AI is not correct. It's just where we are now. But everything that came, it started with the transformer architecture. And transformers is not those transformers that I'm talking about. Is the transformer architecture proposed in this paper that's called Attention is All You Need. It's one of the best papers of the modern era, and it helped all of these models to become what they are today. So without transformers architecture, we wouldn't have ChatGPT, for example. And it's really important. I will show a little bit of how it works, but it's one of the cornerstones. And one thing that's really nice to see, it's really fresh. It's from 2017, so it's something that's really new and not something that was created a long time ago. But all the advances in AI and neural networks allowed us to get here. And just to show a little bit of what a transformer is this. It's really a lot of stuff, but I'll show it in details. Okay, so LLMs, they started being released about 2018, as I showed you. But the way that we use them was with ChatGPT, so that allowed users to interact with those LLMs. And we have, these are a couple of LLMs released only this year. So we're having, what I said, a huge advance in this area. So Llama is developed by Meta, GPT by OpenAI. We have Bard by Google, PaLM by Google as well. So these are really important models, each one with its capacity, with its capabilities, with some different architectures, number of parameters. And just to show you that it's really new, everything that we're working with. And yeah, how are people using LLMs today? So the thing probably everyone already did, in their lives was go to ChatGPT and ask it to do something for you. So if you work with repetitive tasks or anything that can be automated, you may use ChatGPT to help you in your workflows. You may ask questions about things you don't know. And yeah, usually we let ChatGPT do it. If you work with programming, you can see how much it is useful in our daily lives. And yeah, and another way that people use LLMs, it's not by interacting directly with it, but by creating applications for others to use it. So this is what I'm going to go now into, is how can you use those models that are available for you to create an application and use it to create your own custom application for your own custom problem that you want to solve. So I'm going to go a little bit into this now. Don't worry about this diagram. We will go deeper into it right now. Okay, so how can you create tools with LLMs? One of the core concepts here is prompt engineering. Prompt engineering helps to craft inputs. So how are you going to ask something to an LLM, and how to, and you create these inputs optimizing for the best input that you want. So you create better prompts to get better responses. This is one of the core concepts. And if you want to build applications with LLMs, you will have to know prompt engineering. You will have to engineer prompts and test a lot of different prompts for your models. And yeah, this is so important that a lot of papers, academic papers and research are being developed in this area. So just on how you ask things for an LLM can help you gain much more accuracy, much more capabilities with that, with the LLMs and with those ChatGPT models, for example. This is true for people who are building tools with LLMs, but also if you're just a casual user of ChatGPT, if you create better prompts, you will probably get a lot more from the tool than just by writing and throwing stuff in an unorganized way. So prompt engineering, really important, is how you ask the LLM to think. So you can show examples to an LLM. So I want you to write a recipe for me in topics. This is a way to engineer a prompt. So write this recipe for me and list in 10 topics what I need to buy, for example. So these things help a lot to get the desired output from the LLM, even if you're a casual user. But if you want to build applications with code and with the APIs of those LLMs, you will use prompt engineering. Okay, so another thing that's really important and it has a really fast pace as well with LLMs are tools to help you develop those applications. So we have a couple here that are the most common to use and the ones that are being developed faster, but there are a lot new ones coming as well. So Llama Index and LangChain, they are tools to manipulate and to work with those LLMs. So it creates a lot of specific tools that will help you to design your prompts, to chain them together, so put prompts in order. And also here, there are a couple of vectorized databases that I will also tell you how they work. So a normal workflow here is this. I'm going to start talking about the LangChain and Llama Index. Both are in the center because they are what we use to work with everything, work with the APIs, work with the databases, work with the prompts, and put them together. So first thing is LangChain helps you a lot with designing those prompts. So it helps you to pass information from, I don't know, a data set or user input into your prompt. It creates templates. It already has a lot of templates on how do you ask the output of the LLM to be. So you can ask it to be a JSON, for example. This will make it a lot easier for when you're working in your tool to get the response and work with that in a programmatic way. It also creates chains. So chains are basically prompts that work right after the other one. So you create a prompt, then you get the output from this prompt and put into into another prompt, and you can do this with big chains. one thing that I can exemplify this. So you can ask first for a user, what is your language? And he can put Italian, for example, and then you can ask him, and then you can provide him, for example, with a recipe to do pasta in Italian. So you had to ask something, he told the LLM what to do, then you use that information for another prompt. So you can build prompts in a chain. Okay. And also agents. Agents are basically smarter chains. So you can ask the LLM to make decisions and to look at what the other prompt returned and use that to make a decision. So should I use this tool like a calculator? You can create a simple tool with a Python function that allows you to do a calculation. An agent can decide if he wants to use that calculator, and then the agent is basically an LLM, but it wraps around the LLM to be able to interact with tools, for example, and make decisions about which chain do you use. So these are really important for you to build your workflow with your language model. Then the LLMs, you can use a number of APIs. So we have Metas, we have ChatGPT, the GPT OpenAI API, you have Palm, that is the Google API. You can use any of these, and LangChain makes it really easy for you to change between them. So LangChain standardizes the way that you talk to LLMs. So you can, in one line of code, basically change from ChatGPT to Palm without any hassle. So LangChain really wraps around all those things. It creates templates for prompts, for agents, and for chains. Let's talk a little bit about document loaders and vector stores. So as you may know, ChatGPT and GPT-4 and 3 were trained with data up to 2021. So if you want to ask him about LangChain, about the documentation of LangChain, it won't know, because documentation of LangChain wasn't on the internet before 2021. So one thing that we can do is use a document loader. So we can load a document like a PDF of the documentation of LangChain and pass that PDF on a prompt. So this is a prompt engineering, for example. The model doesn't know anything about LangChain, but we can get that specific document, pass it in our prompt, asking for, I don't know, how do I use an agent in LangChain? We can pass the documentation to the prompt and the prompt to the LLM, and then the LLM can answer using that context that we provided with the document. But you may also know that we have a limitation of number of characters we can pass. So if you have a 30-page PDF, you won't be able to pass it all in one prompt. So that's where we use the document loaders to split the document. So we create splits of it. We can get 1 page or maybe half a page per split. And then we have to decide which splits do we pass in our prompt. And that is also something that vector stores can help, but retrievers really help with this. That is by searching, given what you're asking. So if I'm asking about agents in my prompt, I can use a tool by LangChain to select the specific split that will have the documentation for agents and pass only that part into the prompt. So that way we use only the part that's relevant and gives the context that we want to the LLM. And lastly, we have vector stores. Those vector stores, they store those documents. So they store them in a different way. I will talk a little bit about embeddings. That's the way they are stored. And it also helps us to query those documents to find the documents that are closer to what we want. So closer to the query that the user is providing, for example. Okay, this is a lot of stuff, but this gives you an overview of what you need and what you can do with these kinds of tools. A lot of this stuff is free, so LangChain is free, Llama Index is free. Pinecone has a free tier, you can use it for a little. I never used Weaviate in depth, but it's I heard good things. The APIs of Palm, GPT, you have to pay, but they are cheap, so you can try a little to create some tools yourself. But there's a lot of stuff on the internet as well on how to create these tools. Let's show you the example that was on the previous slide. So here we have a front end that can be created with any framework. This is Streamlit. It's really easy to create a front end. And then we have a user that will interact with that front end. And let's think about a specific use case, such as I have a financial report of a company that I want to invest in, and I want to ask questions. I don't want to read the 30 pages of that document. I want to ask specific questions about that document. So an app can do this easily. You basically use a document loader, split that document into chunks, and then we can use that document. We can use the LLM to ask questions about it. And how does this work? You use LangChain with a LangChain as an LLM framework, and it will generate the prompts. It will generate. You will get the specific part that you need to ask about the document, and it will input that to the language model that will return the output that the user wanted. I have a quick demonstration here of how that could work. Let me just show you really fast. This is GPT Investment Banker. I have a financial report here. Just 1 second. I accidentally closed it here. But I have this financial report here about a company. This is a tutorial from YouTube, so this is really easy. You can also do it yourself. It has 312 pages. It's Macquarie company. And here we can ask, for example, what environmental actions does the company usually makes? And that it will get this prompt. Let's look here on how it works. It will get the input that I did. It will use it to find the specific part of that document that I use it. It will then get that part of the document along with my question and pass that to the language model. The language model will read both the document and my question and will output here. So here, Macquarie is implementing a range of sustainable farm management practices. They have registered 2 new environmental planting projects. So it answers with the document that I passed, and here we can see the parts of the document that he used it to answer the question. So this is a really simple application that you can easily do. And let me go back to my presentation here. And this is a way to work with LangChain and LLMs. So yeah, this is just another way to show it. So we get the PDFs, then we split it, store them in the vector store. Then I have a query question that will find the most relevant splits. Then we pass those splits into our prompt with the question, and the LLM will give an answer with that context. So this is from a course on deep learning AI that I will also show you at the end. It's a free course. You can do this really fast. Okay, so what is an LLM really doing behind the scenes? This is really important because we want to know its limitations and be careful to not make assumptions on what it's doing. So remember in the beginning that I said, LLMs are really good at predicting the next word in a given sequence of words. So what does this mean? Okay, first thing, let me just explain a context here about embeddings. So embeddings, it's models and computers. They don't understand language. They don't understand words. So we have to give them numbers. And since we're working with words, with text, we have to make that text become a number. In order to do this, we could get every word in the English dictionary, in the Portuguese dictionary, in whatever, in all the dictionaries, and attribute a number to that word. So woman could be 1, king 2, queen 3. So everything could be a different number. However, words have meaning, and meaning that, and these meanings, they relate to each other. So if I say 3, and if I say that, I don't know, car and person, they are different, but person and queen, they are similar. So we should have some way to make the model understand that. And embeddings does this. Embeddings will get a text like here, canine companion say, and we will have an embedding model that will transform that text into a vector. A vector is basically a lot of different numbers, each one representing one dimension of that text. And here in the right, I have a simple example to demonstrate what an embedding is capable of doing. We could have an embedding with two dimensions, one determining that you can put 0 if it's not royalty and 1 if it's royalty. And in the other dimension, we could put 1 if it's female and 0 if it's male. This way, we can have, for example, queen. When we subtract female from queen, we get king. And when we subtract royalty from king, we will have man, for example. So this is a way that we can train large embeddings to have words relate to each other and to feed them into models. This is really important, and the embeddings normally have a couple thousand dimensions, so they're improving a lot. Going back to what's happening in the model itself. So in the model, we're doing what we call a sequence-to-sequence model. That is what I said, we're completing a phrase. We're using a sequence like an input, and the model was trained to complete that input with an output. So it's a sequence-to-sequence model. This is really useful when we're doing translation, for example. So translation models, they do this. So we have an input in French here. It's a sequence of words. We pass those sequence of words to the transformer here, the model that we're using, and the output, it's an English word. So it's an English sequence. This is what the model does, that a transformer does, but we don't need to use it for translation. We can use it to complete phrases. So how are you can become, we can complete how are you with I am good. So a model would predict those 3 next words like I am good to a question, to an input, how are you? And the embedding is that layer where we put the word goes through the embedding and it goes to the model. So this is what it's doing. Remember that this is the architecture of the transformer. This architecture, I can show you here on the math. This is the math. I won't dare go into it right now, but the attention mechanism is basically this math represented into this diagram, and that we can have multi-head attention. That's a lot of those mechanisms stacked together. If you really like programming, if you really like data science, you should learn this. It's really nice to know how things are working behind the scenes. This is from a course also by Deep Learning AI. This course is paid, but it's really good. And it has a lot of good content. Okay, so our model is really good at predicting another word. I don't know if you noticed, but GPT-3 was released much earlier than ChatGPT. I think it was about 1 or 2 years difference between the release of GPT-3 and the release of ChatGPT, the model GPT-3 and the release of ChatGPT. ChatGPT uses a model that is GPT 3.5. And the difference between those models is what made those big large language models that uses transformers into chatbots that are able to follow instructions and to give useful answers to people, to humans. And okay, so we have these large language models that use this complex math to predict the next word in a sentence. This is what it does. It predicts the next word in a sentence and predicts next sentences as well. But how do we make it follow instructions? This is what is the difference, the main difference between the GPT-3 and GPT 3.5. It was instruction tuned. So we do something that's called instruction tuning and RLHF, that is reinforcement learning with human feedback. That is how we can make that model talk and give useful answers to humans. So let's show you, let me show you a specific example. So we have the input to the model. It's a movie review. This movie is the best rom-com since Pretty Woman. Did this critic like the movie? Options, yes or no. We want the model to answer just about the option. It has to answer yes or no. So we can make, so this is what we want. Instruction tune is basically tell the model what we want it to do, how we want it to complete that phrase. And another one is what is Vincenzo Zhao's profession? Answer in Chinese, and we want the model to answer in Chinese, to follow that instruction, not just complete the sentence in English. So to do that, we use reinforcement learning with human feedback. So we get a lot of prompts here. We pass those prompts to an initial model that's not instruction tuned, and it will generate a lot of outputs. And then a human will score which outputs are more relevant regarding what we wanted it to do. So if we told the model answer it in Chinese and it did not answer in Chinese, we will rank it below, and using that we can create a reward model and do reinforcement learning to make the model learn how to answer and how to complete those sentences in a way that is following the instruction. So this is instruction tuning in RLHF. So recapitulating everything. A model, an LLM, it's a sequence-to-sequence model, a model that was trained on a vast amount of data from the internet, and that is really good at predicting a next word and the next sentence. This is what the model does, text generation. Then we also combine that with instruction tuning and reinforcement learning with human feedback. When we do that, we're basically making the model useful to predict the next word following the instruction that the human wanted. This is what the model does. We have to keep that in mind all the time, because the model is not sentient. The model is not doing something that it never saw before. He only knows what to do and what to predict from the text that it learned, from the internet. So when we look at the output from a model, we have to keep this in mind. This is really important to know the limitations of that model, up to what it's capable of and what it's not capable of. And talking a little bit about AGI, that's artificial general intelligence. This is one thing that people say that GPT-4 is approaching, but this, we can define it as well, is an AI that possesses the ability to understand, learn, and apply knowledge across a broad range of tasks at an equal level or beyond human capability. That's a simple explanation. We can go into a lot of different stuff, like what is intelligence, and other stuff. But the model is not equal or beyond human capability because it is not that good in using tools. It cannot use things that it did not see before. So that's a lot of discussion in this area, with some people saying that GPT-4 has sparks of AGI, of artificial intelligence. That is a paper from Microsoft Research. They show that GPT-4 can already use tools. It can learn how to perform some tasks. So there are some studies in this area saying that we are close to AGI. However, there are people like Ian LeCun. He's the head of data science and AI at Meta, Facebook, and he says that he has a open review paper that's a path towards autonomous machine intelligence, that he proposes something really more complex to get close to AGI, because we have to have perception about the world. We have to have some short-term memory, world model, have to have a lot of components like a brain, like a human brain, to have autonomous machine intelligence, or AGI. So this is a discussion that's happening. There is a podcast by Sam Altman, the CEO of OpenAI, with Lex Friedman. That's really good. They talk a lot about AGI, how close we are, what are the discussions in this topic, and I really recommend. Also, I recommend both of these papers that I have linked here. Okay, so this is the talk that I wanted to show you. I wanted to show you first what is AGI, what is a sorry, what is how to create powerful and easy tools with LLMs. I didn't show you, but it was about 50 lines of code, that specific implementation that I did. That I actually wasn't it was from a YouTube tutorial, but it's really easy to do, and it's easy to create applications. However, we have to be careful about the limitations and what the model is really capable of doing. So it's really important to understand what is happening, what the model is doing, how is it creating that response, what it's making it create that response, those responses. So there are a lot of concepts that I passed briefly, and I highly recommend to dive deeper into them. And yeah, for our last session, just some tips on how to start in AI and working with LLMs. Immerse yourself in AI. This is something that I really like. So go deep, read books, read articles, watch movies, watch The Matrix, watch iRobot, watch all those movies that talk about intelligence and talk about artificial intelligence. Do courses, try to program, try to code. It's really important if you want to really immerse yourself on all types of contents. Also, a framework that I really like for learning new stuff, it's study, apply, and teach. So study, watch courses, see tutorials, read articles, then apply it into a problem, code it yourself, find a problem that's relevant to you, and then try to teach to someone what you did, because this will help you cement that knowledge much better, and it also can help you get some jobs, because you can post those things in your GitHub and your Kaggle, and this will help you a lot. Then start looking for a job, start applying that into real life problems. They are really different from the ones that you find on Kaggle. That is a website that you have a lot of data sets and competitions. But start looking for a job or create your own company. Try to solve real world problems. That it's one of the main things here. And yeah, some free resources that I highly recommend. This one is, I think everyone should do it. It's the Deep Learning AI course. They have a lot of short courses that they are releasing. I think they have about 6 courses right now. All of them are with LLMs in mind. So how to build systems with ChatGPT API, ChatGPT prompt engineering for developers. I think everyone who knows basic Python should do this course, because it shows you how to really do prompt engineering, what are the techniques, and how can you leverage those prompts to put an API of an LLM into a framework. So those two are really good. There is a Langchain. There are a couple of Langchain as well here. So I highly recommend those courses. They are free. They say that they are free for a limited time, so I recommend everyone doing them. Also, there are a couple of YouTube channels. Greg from Data Indie has a lot of content on LangChain, so his content is really good to get started with this tool. And Kaggle has a lot of data sets as well. So you can find data to work with your LLMs, and can try to find competitions as well that could help you to try to solve real problems and to apply what you're learning on those courses. So yeah, this is my talk, and I'll answer some questions from the chat now. Let me see here. Do LLMs immediately use previous prompts, like if they're similar, when attempting to find answers? Okay, immediately use previous prompts, like if they're similar. Yeah, it depends. So if you're working with ChatGPT, it has a context, so you can tell him in the first prompt, "Hi, my name is Gabriel," and in the you can talk about different stuff. Ask him who's the United States president, I don't know, and then you can ask, "What is my name?" The ChatGPT will have that context. But when you're working with the API, for example, you don't have that context. So if you want to create a chatbot using the API from ChatGPT, you have to store that context. So if I tell the model not on ChatGPT, but using the GPT API, like my name is Gabriel, then I talk about some different stuff, and then I ask it again, what is my name? It won't remember. So if you want to create a chatbot, for example, outside of ChatGPT, you have to store the conversation and pass it in the prompt. So you have to keep a log of that conversation. And LangChain helps you do this. It's really nice. It stores everything that was talked with the LLM. So what was my input and what was the output from the LLM, and you can pass that on the next prompts as context. This is really nice, and you can also do this in a couple of different ways. So you can remember just the last conversation, or it has some other mechanisms to remember and to summarize that conversation. So if I did a huge conversation with the LLM, and I cannot pass all that conversation into a prompt, I can ask. LangChain has a framework to ask an LLM to summarize that content and just store that summary of that conversation. But yeah, answering your question, ChatGPT does that for you when you're working, when you're using the browser. But when you're using APIs, you have to provide that history of chats with tools yourself and inside the prompt. Okay. Next question. What is your advice for software engineers wanting to get into LLMs? Should we be proficient in ML AI first? Okay, that's a great question. No, you don't have to be proficient, but it's nice to understand like what's happening behind the scenes, like this, like what I showed you. What is the limitations from that? But if you can build anything with that solution and you think you can help to solve a problem, you should do it. But understanding machine learning and understanding AI can help you go deeper. So if you have just a basic Python knowledge, you can build great solutions with those LLMs. But if you want to go deeper and create more complex stuff and really understand and try to create your own LLM, fine tune your LLM, you will have to know a little about machine learning. If you want to fine tune an LLM by hand, you will have to know a lot. But yeah, you don't need to know a lot of ML AI, but you should, if you want to use LLMs, you should try to be curious and ask what's happening and try to understand those things, because it will help you in the long run. Okay, everybody shifting to RLHF. How do you safeguard again human feedback in the loop? You think soon we're going to be reinforcement learning? Yeah, okay. Yeah, that's a good question. This is something that all the companies, they are looking into it. So I remember from this podcast that I mentioned, Sam Altman, they have a huge area inside the company just focused on the human feedback loop, because we can easily make that model have some biases just by that human in the loop, just by the reinforcement learning with human in the loop, because a human is deciding what is the best way that answer the question. This is the problem, and also the data. The data can be biased, so we can have a lot of biased data that we're feeding into the model that will also create a lot of problems along with the human doing the reinforcement learning. So yeah, this is a really hard question, because if we want just the AI to fine tune itself, we will have the human out of the loop. But this way, it's really hard, especially when working with text, to create what we call a loss function and a reward function. How do you make an AI tell which output was best to a human just by looking at the text? This is hard. It's a really hard problem, and I'm not studying that a lot. But I know that the companies are, and I don't think we're going to go a lot to AI being providing that reinforcement learning. But that's my opinion. I think the human should always be in the loop, but we should have strategies and processes to safeguard from those biases. Okay, nice. First time hearing about the concepts of chains in this context of for prompts. Yeah, chains are really nice. Chains are really important, and they can help you make a lot of good solutions just by using the chains. You don't have to use agents, but if you use chains and document loading, you can create very powerful tools. And I highly recommend trying to look at some quick tutorials on YouTube. They have a lot of tutorials on how to build a app with LangChain. Just search that. You will find a lot of applications using those two things. Okay. What would you say is the biggest limitation with LLMs? Yeah, okay, so that's also a question that I think maybe more philosophical, but yeah, they are prediction machines. They are text completion prediction machines, so they are not able, and these can contain a little bit of opinion too, but they are not able to be creative. They just repeat what they saw in the past. So this, I think, it's a limitation. We saw with AlphaGo, that's completely different from LLMs, but it uses reinforcement learning and uses the AlphaGo, the alpha. I forgot the name of the algorithm, but it uses the AlphaGo algorithm specifically to play the Go game. And it was, some specialists in Go say that it made a creative play. So I don't know if it's the LMs are really, really, really not creative, but the limitations, I think, are the amount of data that they had, the possible biases that those data and those feedbacks and reinforcement learnings could contain. So these are also a limitation right now. And yeah, limitations for philosophical reasons are these biases and and what it's capable of doing. But it has a lot of limitations, like you can pass whole text, so that the number of tokens you can pass, it's limited right now. It's increasing, but it's not that huge. Yeah, I think that those are the specific limitations. Yeah, I don't think there are more questions. If anyone has any more questions, feel free to ask. But yeah, if there aren't more questions, thank you for your time. You can reach me in my LinkedIn. So my LinkedIn is Gabriel Casimiro. Also, if you speak Portuguese, check out my my YouTube channel. And yeah, thank you everyone for your time.